radii of the same circle. First circle OA-OB, second circle OA dash O dash B. O dash is common. Therefore, by triple S property, these two triangles are congruent. By CPCT, 1 is equal to 2. By CPCT, 1 is equal to 2 children. Now, consider triangles AOM and BOM. In triangles AOM and BOM, AO is equal to BO. Given 1 is equal to proved above. OM is common. By SAS property, these two triangles are congruent. By SAS property, these two triangles are congruent. By CPCT, AM is equal to BM. By CPCT, AM is equal to BM. And angle 3 is equal to angle 4 by CPCT. But 3 plus 4 is equal to 180 by linear pair. 3 is equal to 4. 3 plus 4 is equal to 180. Now, in the second case, 4 is replaced by 3 because 3 is equal to 4. So 2 times of 3 is equal to 180, 3 is equal to 90. Therefore, OO dash is perpendicular bisector of the common chord AB. Hence it is proved. Once again I am saying children, prove that the line segment joining the centers of those two circles will be perpendicular to the common chord. When two circles intersect at two distinct points, A and B, the line segment joining the centers of these two circles OO and O dash will be the perpendicular bisector of the common chord AB. Therefore, to prove that AM is equal to BM and angle AMO is equal to 90, construction join OA, OB, O dash A, O dash B. Now come to proof. In triangles, AO, O dash and BO, O dash. In triangles AO, O dash and BO, O dash. AO is equal to BO, radii of the first circle. AO dash will be O dash, radii of the second circle. Then OO dash is common for both. Therefore, by triple S property, these two triangles are congruent. By CPCT, 1 is equal to 2. 1 is equal to 2. Now, consider triangles AOM and BOM. OA is equal to OB, radii of the same circle. 1 is equal to, proved above. OM is common for both the triangles. Therefore, by SAS property, these two triangles are congruent. By CPCT, 3 is equal to 4 and AM is equal to BM. 3 is equal to 4 and AM is equal to BM. But 3 plus 4 is equal to 180 by linear pair. So 2 times of 3 is equal to 180. So angle 3 is equal to 90. Hence OO dash is perpendicular bisector of the common chord AB. Otherwise, we can say angle AMO is equal to BMO equal to 90 degrees and AM is equal to BM. Therefore, OO dash is a perpendicular bisector of the common chord AB. Hence it is proved, children. Full proof is over. See, the construction. Uh, we have proved these two triangles are congruent. Next now. First pair congruent, second pair congruency. Linear pair. Bisector. Hence it is proved. Over. Okay, children. Please do it immediately. Children, please do first problem immediately. We have time, don't worry. Do it. Did the work is the work posted, children? Is the work posted to you, everybody?
Yes, sir.
Very good. Viti Gopalam, Happy New Year.
Thank you, sir. Same to you.
You didn't come yesterday. Any problem?
Yes, sir. Net issue.
Outside. You are from which school? Bhavans only.
Once.
Bhavans, okay. The first problem I said now, look at the figure. Jaitriya, so Jaitra, you are late by 15 minutes. Okay, once again I am saying the first problem which is important. Follow carefully both of you. Two circles are intersecting at two distinct points A and B. Join AB. Chord is formed for both the circles. That's why it is called common chord. Jimbuvardhan. Happy New Year.
Thank you, sir.
You didn't come yesterday.
Sir, I have class, sir.
Then why you did not tell me? Okay, now look at the presentation. Two circles are drawn. These two circles are intersecting at two distinct points A and B. O is the center of the first circle, O dash is the second center of the second circle. Line segment O dash is joined. AB is the common chord. Once again I am saying two two circles COR and CO dash R dash are intersecting at two distinct points A and B. Their centers are O and O dash. Then join O dash. It's a line segment formed by joining the centers of two circles. Join AB is a common chord. It's a chord for both the circles. That's why it's called common chord. To prove that, the line segment joining the centers of two circles will be the perpendicular bisector of the common chord AB. So we have to prove that. And the line segment O dash is intersecting the chord AB at the point M. To prove AM is equal to BM and angle AMO is equal to 90 degrees. Angle AMO is equal to 90 degrees that we have to prove. Okay, children. Coming to proof. Before that construction, join AO dash. Join BO dash. Construction over. Next, proof. Consider triangles AO dash and BO dash. AO dash is a triangle above the line segment O dash and below the line segment O dash OBO dash. Consider triangles AO dash and BO dash. In these two triangles, AO is equal to BO, radii of the first circle. AO dash equal to BO dash, radii of the second circle. O dash is common for both. Since AO is equal to BO and AO dash equal to BO dash, therefore, and AB is common, therefore these two triangles are congruent by Triplets rule. And these two triangles are congruent by Triplets rule. Therefore, one, CPCT 1 is equal to 2. AO dash BO dash congruent. Therefore, 1 is equal to 2. Now consider triangles AOM and BOM. What is M? M is a point of intersection of the common chord AB and the line segment joining the centers of two circles. That's called intersection point M. Now consider triangle AOM and BOM, in which AO is equal to BO, radii of this first circle. 1 is equal to, proved above, OM is common. Therefore, by SCAS property, these two triangles are congruent. By CPCT, angle 3 equal to angle 4, and angle and AM is equal to BM. But angle 3 is equal to 4, but 3 plus 4 is equal to 180 by linear pair. 3 plus 4, 180 by linear pair. So 2 times of 3 is equal to 180. So angle 3 is equal to 90 degrees. Hence, O dash is perpendicular bisector of the common chord AB. Hence it is proved, children. Please write down immediately. So when you are a bit late to the class, Happy New Year, Sean Chandrasen. Sean Chandrasen, Happy New Year. Are you able to hear? Okay. Hmm. Okay. Any doubt? Yes, sir. I am ready. Any doubt? Hmm. Okay, children, I'm going to second problem now. Difficult problem. Two circles radii 17 centimeters, 10 centimeters. Two circles of radii 17 and 10 centimeters intersect at two distinct points PQ, and the length of the common chord is 16 centimeters. PQ is 16 centimeters. Find the distance between their centers. So AO plus BO we should find out, add both to get AB. So then look at the figure. Two circles intersecting at two distinct points P and Q. A is the center of the first circle, B is the center of the second circle. Now AB is a line segment joining the centers of both the circles intersecting the common chord at the point O. At the point O. Once again, children, two circles are intersecting at two distinct points P and Q. A and B are the centers of both the circles, and the line segment joining the centers and the common chord PQ intersecting at the point O. Find the distance between their centers. AB is equal to how much, children? AB is equal to how much? What they gave, radius of the first circle is 17 centimeters. Second circle is 10 centimeters. This is a 17, this is a 10. And the length of the common chord is 16. This is equal to 16 centimeters, children. This is 16. Okay. Hmm. Find the length of the common chord. Sorry. Find the distance between centers. So AB is equal to how much? So first I should find out AO, then I should find out BO, join both to get AB. Then how to find out AO? We know AP and we know PO also. We know BP and we know APO also. So AO you find out, BO you find out, join both to get AB. This is based upon previous problem only, children. This is an application of the problem. That is a theory, this is an application. What is the theory we require in this problem? The line segment, the problem only we should write here.
That's 21, sir.
1 minute, somebody came. Samhita. Samhita, why do you come late? By 6 o'clock only class start, you know. I told you 2 or 4 days back only, we are starting the class by 6 o'clock only. Yes or no, Samhita? You forgot about that. Samhita, good morning. Happy New Year. Samhita, are you able to hear? Samhita, Sahu, you both came late to the class. Class started by morning 6 o'clock, you know, I told you very clearly.
So class starts from 6:30, right?
No, please, 6 o'clock only, no. I told you I don't have 10th class in the morning. Now I'm starting one afternoon before only so that I can teach leisurely. We can spare more time for you. I can clarify some majority children's doubts. That's why I'm taking from 6 to 7:30 now.
Okay, sir.
Ah, even 2 days back also I said even for some that she came by 6:30. I told her class not by 6:30. You come by 6 o'clock. I said. In spite of that, again she came just now by 6:30. Samhita, any problem? No answer.
No, sir, I forgot actually.
Okay, that you should say immediately. Know what happens. Why you take so much time for that? Okay, from tomorrow come by sharp 6 o'clock. Okay, good girl.
Okay, sir.
Okay. Okay, let me complete second problem now, and then I'll go back to first problem for both of you. See, after this I'll teach you first problem. Don't worry. In the meantime, they'll be doing this. In fact, this problem is application of the first problem only. Here, two children, please follow the figure. Two circles are intersecting at two distinct points P and Q. A and B are the centers of both the circles. Radius of the first circle is 617, second circle is a 10 only. The common chord length is equal to 16, PQ is equal to 16, AP is equal to 17, BP is equal to 10, PQ is equal to 16. Find AB. AB means I should find out AO as well as BO. Both we should find out separately, then add both to get AB. Easy problem, but lengthy problem, children. Children, here. First, you should write the property. What we have proved in the previous problem that we should write here. The property. Some people say we don't, that is not a property, you have to prove it. Some people say that. Some people say that you have to prove the first problem. So I have proved the first problem. Then based upon that, I have done the problem. So it became lengthy. In fact, the property is not there. We know the property is not given as in the header as a property. But what should we do for this problem? This entire first problem, what we have done, that we should do for this problem now. Lucky for the sake of the children who came late. Children now. What we have done is the first problem. Once again, I'm saying, please follow. Mm, What is given? Given two circles, P and Q. A and B are the centers of both the circles. Radius of the first circle is 16 and second 17, and the radius is 10. And the common chord length is 16. Find the length between two centers A and B. Now come to proof. Consider triangle PAB and QAB. Consider triangle PAB and QAB. In triangle PA is equal to AP is equal to AQ, and BP is equal to BQ. AB is common. AP is equal to AQ, BP is equal to BQ, and AB is common. Therefore, the triangles PAB and QAB are congruent by triplets property. PAB and QAB both are congruent by triplets property. Therefore, by simplicity, 1 is equal to 2. By simplicity, 1 is equal to 2. Okay, children. Now consider triangle APO and BPO and APO and QAO. APO and AQO. APO, AQO, both the triangles I'm considering. In which AP is equal to AQ. How? Radius of the first circle. 1 is equal to 2, proved above. AO is common. Therefore, triangle APO is congruent to triangle AQO by SAS property. Once again, children. First, we have proved PAB, QAB are congruent by Triple property. CPCT 1 is equal to 2. Now I have taken AOP triangle, AOQ triangle, AOP triangle, AOQ triangle, in which AP is equal to AQ. Given 1 is equal to 2, proved above, AO is common for both the triangles. Therefore, these two triangles are congruent by SAS property. By CPCT, 3 is equal to 4. And by C 3 is equal to 4. And by CPCT, PO is equal to QO. But 3 plus 4 is 180 by linear pair. Therefore, 2 times of 3 is equal to 180 and angle 3 is equal to 90. Therefore, AO is perpendicular bisector of PQ implies AB is perpendicular bisector of PQ. Okay. So, triangle AOP is right triangle now. Triangle AOP is right triangle in which hypotenuse is 17, one side is equal to 8 because bisector, half of it is, this is 8. Then this is 17, this is 8. This we should find out. AO we should find out. 17 is AP, this is 8, this we should find out. AO answer is 15. Children, 8, 15, 17 Pythagoras triplets. 8, 15, 17 Pythagoras triplets. 17 square, 289. Now the other one is what? 8 square, 64. 289 by 64, 225. Square root is 15. 8, 15, 17 Pythagoras triplets. So AO is equal to 15. Come to next triangle BPO. PB is equal to 10. PB is equal to 10. PO is equal to 6. Not 6, 8. Got 16, So 8. Then PB is equal to PB is equal to 10. This is equal to 8. This we should find out. Children, 6, 8, 10. Pythagoras triplets. 3, 4, 5. 6, 8, 10. One is 6, one is 8, one is 10. Now, we have proved these two are congruent, these two are right triangles. So I can make use of Pythagoras theorem. Angle POB became 90, PB is equal to 10, PO is equal to 8. By Pythagoras theorem, we get BO is equal to 6, 6, 8, 10. So BO is equal to 6 and AO is equal to 15, 15 plus 6, 21. Therefore, the length of the line segment joint centers of both the circles is equal to 21 centimeters. Children, answer 15 plus 6, 21 answer. We'll check the answer what we got. Same answer, children, 21 centimeters. This is a lengthy problem, children. First part we have to prove it. Then second part, two triangles are there, congruent triangles. Then with the help of those two triangles, we can find out the distance between the two centers. Okay. Once again, children. Here this is 17. This is 8. This is 15 by Pythagoras triplets. 8, 15, 17. So it's 15. Now second triplet now. This is here this is 8. This is a 10. This will become 6. Second congruency, this one in triangle POQ, BOP. This is 10, this is 6, 8, this is 6. So 15 plus 6, 21. The length of the line joining the centers of both the circles is equal to AB is equal to 21 centimeters answer. Okay, children. So first problem over, second problem over. Please do second problem neatly and correctly. Second problem, very lengthy problem, children. First problem plus second, two parts are there in that. Okay, children, I'll teach you now third problem. Afterwards, you can continue the work. Third problem, children, look at the presentation. A cyclic quadrilateral is drawn inside the circle. A cyclic or ABCD is drawn inside the circle and it became, one of you continue, and it is,
Cyclic quadrilateral.
I said the same thing, A cyclic quadrilateral is drawn inside the circle and it is also
A trapezium.
Trapezium.
trapezium. How do you know it's a trapezium, children?
One pair of opposite sides are parallel.
Very good. AB parallel to CD. So it is a trapezium. Angle D now 70 degrees. Angle D 70 degrees is an application, children. Now see the problem. What is to find? Given in a cyclic quadrilateral, AB is parallel to CD and angle D is equal to 70 degrees. Find the remaining three angles of the quadrilateral. Find the remaining three angles, children. Basically, the cyclic quadrilateral property. One of you say that property. I want the property. Let cyclic quadrilateral.
The
Opposite
sum
angles
of
of a cyclic
pair of
quadrilateral are
opposites.
supplementary.
One important word is missing, children.
The sum of either pair of opposite angles in a cyclic quadrilateral is 180 degrees.
Very good. Sum is important. So A plus C 180, B plus D 180. But D is equal to 70, therefore B is equal to 110. Since D is equal to 70, B is equal to 110. One property, one angle we got it. B is equal to 110. Then second one, children. Is AB is parallel to CD. One of you continue. AB is parallel to CD.
Therefore, angle A plus angle D is equals to 180 degree
You,
pair of consecutive interior angles.
I said I said AB and CD are parallel lines. You should continue with one more word. AB and CD are
ATM
parallel lines. AD is
transversal.
AD
Therefore,
is sum of the consecutive interior angles property. When two parallel lines are intersected by transversal, sum of the consecutive interior angles are supplementary. Therefore, angle A plus angle D is equal to 180, but D is equal to 70 degrees. Therefore, angle A is equal to 110 degrees. Angle A is 110, angle B also 110 because of opposite angles of cyclic quadrilateral 110. Then what about angle C? Angle C will become 70 only. Same answer. How do you know? Somehow the four angles of quadrant 360 degrees, we can find out the fourth angle. Okay, children. Once again, I'm saying, given ABCD is cyclic quadrilateral, not only that ABCD is it is a trapezium in which angle D is equal to 70 degrees. Find angle ABC, find angle A, angle B, angle C. First, proof or solution. We know in any cyclic quadrilateral, sum of the opposite angles are supplementary. Implies angle B plus angle D is equal to 180. But D is equal to 70, therefore angle B is equal to 180 plus 7, 180 minus 70, which is equal to 110 degrees. 110 degrees. And we know AB and CD are two parallel lines. AD is a transversal. When two parallel lines are intersected by transversal, sum of the consecutive interior angles are supplementary. Therefore, a plus D 180, but D is equal to 70. For A is equal to 110. When A is equal to 110, C also, A plus is 180, So when A is equal to 110, C will become 180 minus 110, which is equal to 70. We found all the three angles over. Children, now fourth problem. This is also application. Given triangle ABC is an equilateral triangle. So AB is equal to BC is equal to AC. Marking is given. AB is equal to BC is equal to AC. Then what about angle A, children?
60 degrees.
60 degrees. When angle A is equal to 60, what is angle D?
60 degrees.
How do you
Angles in the same segment of a circle are equal.
very good. Angles in the same sigma circular equation. Yesterday we have proved it. Angles in the same sigma circular equation for A is equal to D. Since A is equal to 60, angle D is equal to 60. Then what about angle E, children?
120 degrees.
How do you know?
So sum of the opposite angles of a
How do
quad.
you know? How do you know? We know ABEC is or DBEC is
A cyclic quadrilateral.
quadrilateral. Some of the opposite angles supplementary, but angle A is equal to 60 and angle BEC is equal to 120 degrees. Over children. First one, since three properties are there in this problem. Since triangle ABC is equilateral triangle, each angle 60 degrees, therefore angle BAC equal to 60 degrees. One mark over now. Second mark. We know angles the same segment circle are equal. Therefore, angle A is equal to angle D. Since angle A is equal to 60, angle D is equal to 60. Second mark. Now third property, third mark. We know in any cyclic quadrant, sum of the opposite angle supplementary. Therefore, angle A plus angle E is equal to 180. Angle A plus angle E is equal to 180. But angle A is equal to 60, therefore angle E is equal to angle A equal to how much? Hmm. Angle E, how much, children?
120.
120 degrees.
Very good. Over. Everything is over, children, now. Now you start working all the problems. Please do it.